Is it working? Okay. Sorry about that. This is not working very well. So hi everyone, I'm Anna and I'm working here at Zalando as a data scientist, and today I'm going to talk about recurrent neural networks in natural language processing. So first I'm going to introduce a bit why deep learning for NLP, then I will introduce word embeddings and why they are useful to go next with recurrent neural networks, and then I will show an application for these type of networks, and finally I will share some tips for upskilling in this topic. So before that, I'm going to introduce Zalando because probably some of you don't know because we don't sell in Ireland. But Zalando is the biggest fashion platform in Europe, and we have more than 1,600 people in tech only. And our purpose is to deliver a world-winning and best-in-class shopping experience. We have more than 20 million active customers, and within our principles, we have radical agility, which is we have purpose, autonomy, and mastery in each of the teams and for the persons. So here in the Fashion Insight Center is the research and development center that Zalando has in Ireland, and it was founded with the aim of understanding fashion with technology. So we work with some of the research data sets, both from customers, products, profiles, content, etc. And we have mainly three big teams that are divided into sub-teams. The first one is the smart product platform that are focused in things related with the Zalando platform. Then we have the customer data platform that focus more on customer data and how to improve the experience of our customers. And the third one is the fashion content platform, which are teams that work more with content, and I'm actually in this third one. So I'm in a team that focuses on NLP. So why could it be useful for anyone in fashion to understand, to use NLP? Well, we don't aim to replace a stylist or anyone, but we can help them, right? So for example, in things like what is trending or what's gonna be trending, what are gonna people be wearing next year, right? Because there's a lot of information out there that we could be using. And in that way, we allow people within the company to make data-driven decisions. The thing with fashion text is that text in general is complex, but fashion text is quite complex, and it has a lot of challenges because it's very informal, it has a lot of stylistic variants, and also it has a lot of rich in-domain specific language. I've learned a lot of English these years. So for example, these are only two real examples of text. So the new crop of fallbacks is sumptuous parade of rich jewel tones from Alexander's Wallage Mate Emerald to La Manche decorated sapphire, from Jason's Wood gleaming garnet to Marc Jacobs quilted topaz. I mean, there are three words that I understand. So fashion text is actually quite complex, as you can see there, and these are just two random examples. So why deep learning for NLP? Well, we all know that deep learning is having a transformative impact on the way that we work, right? And the way that machine learning has been applied until now. NLP was somewhat behind others some years ago, as compared, for example, with computer vision and other applications, but this has changed a lot over the last years because of the use of NNNs, LSTMs, and also word embeddings. So there are different areas that benefit from this. So for example, name entity recognition, post tagging, chunking, parsing, etc. So probably many of you already know about what a word embedding is, but I'm just gonna do a refreshing mind. So when we use images or speech, we can encode, for example, in images we have pixels, right? And they have a relation. But what happens with text? Well, if we represent words as IDs, these encodings are going to be arbitrary, because I can say, okay, dog is going to be 1 and cat is going to be 2, but how do I know what's the relationship between them, right? And also, the data is going to be very sparse. So a better representation for words would be a continuous vector space, where each of the vectors is located next to words that have a similar meaning or context. So what we have done is to learn word embeddings in order to represent the word. So for example, we could be using scriptgram or SIVO. So with SIVO, what we're going to be doing is we're going to be predicting target words for the context. So for example, if I have the sentence Zalando meetup talk, I'm going to try to predict what's the word that would be between Zalando and talk. And the contrary for scriptgram, so it will predict context words from target words. So in this case, it would have to predict Zalando and talk. This has become, using word embeddings has become a standard pre-processing step in most of NLP tasks. And it's also used as a feature in some traditional machine learning approaches, such as, for example, using clusters of word embeddings into, for example, an SVM. Well, there are several parameters that you can experiment with, for example, the size of the word embedding, the context window, etc. So TSNE is something that we could use to reduce the dimensionality of the data, because when we're calculating the word embeddings, they may have hundreds of dimensions. So if we want to gain more knowledge about where the words are located, we could use this technique to the visualization. So for example, in this image, I'm showing some data from, okay, can you see the pointer? Okay, so here, for example, you could see that things like paradise, beach, Thailand that are similar are joined together. Here we have protein, foodie. You can see that this comes from some hashtags. And then there are more examples around here where you can see that words that share similar context or meaning are clustered together. And another example would be this one, and this is also using fashion real data. So for example, here we could see, this is just a sample from the data. So here we could see that things as jeans, jackets, pants, dresses are clustered together. Here, I mean, this doesn't give much information, but all the pronouns are clustered here, right? So in this manner, we can have a visual understanding of fashion data and how different terms are related. So now I'm gonna talk a bit about recurrent neural networks, right? So why don't we use basic deep nets and just use a regular deep net? Well, the problem with them is that traditional neural networks do not use information from the past. So each entry is independent from the others. So this is fine for several applications. For example, if I'm trying to classify images, I don't need to know anything about the previous image. I'm just saying this is or this is not fashion, for example. However, things that have sequential information, like for example video, language modeling, speech also, rely on what somebody has said in the past in order to understand what's happening now. So recurrent neural networks allow this. So for example, probably you wouldn't know or you wouldn't understand well what I'm saying if you hadn't heard what I'm saying before. So they're particularly useful in language models. So language models compute the probability of an occurrence of a number of words in a particular sequence. So this is useful, for example, in machine translation, or it also allows us to generate text. The problem with the traditional approaches is that this would normally take unigrams, bigrams, or trigrams, whatever, and a certain window into account, but this is sometimes is not enough. Like to have, for example, the 3 previous words into account, but you don't have the whole history or a longer history. So that's where RNNs come into the game. So basically what an RNN is gonna do is it's gonna make use of sequential information, right? So we have our sentence that we're gonna have time steps, and basically they are recurrent because they perform a task, the same task for every element of a sequence, right? So you can think about a sentence as a sequence of words, right? That we have compared, for example, to words. So basically what these RNNs do is that they have memory. So they keep an internal memory that will allow us to take into account the past. For example, here, what we see is that we are inputting words x to the minus 1, and also this given space. So we see that by inputting this, we're taking into account the past, and we can do it here in different ways, right? So to compute the actual given space, we're going to input the current word and the previous one, and then we're going to output kind of vector as well. And we will do this this, and then I mention it again 20 steps after, I know that I have spoken about that. So this will be an example. For example, say that you are inputting the word, the sentence what is said, right? So I input what, and I input a given state, and the person initialize depending on your problem, and then you have a likelihood of which is going to be the next word. For example, in this case, right? So then you input it, and when you're inputting it, you're taking into account that the previous word has been what, and so on and so forth. Well, and also there are different dominant architectures depending on what's your problem. So in the first one, it's just a normal one in, one out, fixed type normal deep neural network, right? But for example, in the second one, one-to-many, we could be using it, for example, for image description. So what we do is we input an image and we generate words for this. And I actually recommend this blog very much if you want to learn more about RNNs. It's pretty cool. Then we could have many to one. So for example, I'm inputting words and I want to classify the sentence. Many to many, an example would be, for example, machine translation. So here I'm going to input my Spanish sentence, and here I'm going to get my English translation, right? And the last one could be, for example, for video processing. Okay. Hola. So the thing with RNNs is that in theory they can handle long-term dependencies. So they could remember all the history and take it into account properly, right? But the practice is a bit different because, as I said in a previous slide, the parameters are shared by all the time steps in the network, right? So if we're calculating the gradient, we're going to calculate the gradient for all the time steps. And what happens when we do that is that we have backpropagation through time. And what's going to happen is that the gradient could grow massively or could vanish, right? So these type of networks have two problems: plotting gradients, which are easy to spot because you see that your error is growing a lot, and you can easily fix this by clipping the gradient to a maximum, so you don't allow it to grow it more than a certain amount. And the second problem is the vanishing gradients, and that's harder to identify because in theory your gradient should be decreasing as you train your network, right? There are some solutions. For example, you can initialize the matrices to the identity matrix, or you can use ReLUs instead of sigmoids as the nonlinearity. But another thing that you can do is you can use LSTM cells. So as I said here, well, this is another example of really of fashion text, right? So here, after all this sentence, I would like to know what would be the word that I have to say here, right? But it's an information that is really far away. So maybe if I use a normal RNN, that's not going to be able to handle that long-term dependency. So LSTMs avoid the long-term dependency problem. And how do they do it? Well, they remove or they write information to the cell state, and they regulate it using different gates. So these gates are just letting information flow, or they stop it. So it's as simple as that. So I'm gonna briefly explain how they work, right? So here we have, so they basically have some gates, as I said. So in this one, let me check it here. So so first, one thing that we have to do is we need to calculate a new memory, right? So the new memory is calculated in order to capture the new information of the information of the new word. But then we need to decide, does this word matter? So the new information of the word, is this important or not? So this gate will control how much of that new memory that we calculate here is going to flow. Then we have a forget gate, and this is basically calculating how much of the previous memory, cell memory, should be forgotten, right? How much do I want to forget from the previous memory? And then what we do here is we calculate the new memory, and finally we have this gate that is an output. So it exposes how much of the previous memory should be exposed in the new hidden state, right? And with that, we can calculate, we can solve the problem of the long-term dependencies by learning how much should I let go through or not. And again, this blog post is really useful for understanding this. So now I'm gonna, in Zalando, apart from the work that we do in our day-to-day basis, we have a week that is called the Hub Week, where you can propose a project, and if you find people that want to join you, you can work on it, and it's interesting enough. So this year, what we did was to build different deep learning models and architecture for different problems, and one of the things that we did was to build a fashion text generator with real fashion data, right? And just as an example, so these are two samples of text. So would you know which one is fake and which one is the real one? And my answer would be both are fake, but no, there's one that is real. So the one in the right is the fake one. So this was just like a quick experiment that we did, but you can see that deep learning has a lot of power, and even more when you have data to play with. And finally, so this is more for people that are starting and that want to learn more about deep learning, how to upskill, and also how to apply how to upskill in a delivery team, because in Zalando we not only do the prototypes and the research, but we also need to take into account all the production considerations, because our system, all our models are, or almost all our models are used in production. So when you're building your models, you need to have that into account. So you can have, if you want, you can have a look at our blog post. So my tips would be compile resources, and this is important because there are millions of resources, so try to filter on what you are interested and which ones are quality. Choose a course. So if you're trying to learn TensorFlow, which is what we are using at the moment, I would advise to do the deep learning by Google, which is, the lectures are not very into depth, but if you want to just play around with TensorFlow, that would be fine. And then if you're interested in NLP, the NLP classes in YouTube are really interesting, and well, mostly read a lot of papers and get hands-on, because there are a lot of resources online that you could be using. So in GitHub, for example. And, doesn't work. So that's it. Yep. If you have any questions. Please, yeah.
Test. Hey, what sort of infrastructure do you have to run RNNs?
So you mean? So you mean to for the training and or for when we have it in production? So we are experimenting with different approaches. So we're using AWS on one hand, but there's the TensorFlow serving. So we're experimenting with different things. We also have GPUs clusters where we do our experimentations. But yeah, we are still. That's one of the interesting problems that some of the engineers are trying to solve right now, because there are, when you're trying to build models, there are more considerations when you're trying to do it in deep learning, when you want to have them in production, than your usual, you just have it, you just deploy your model and that's it, and it's working. So yeah, that's pretty interesting.
Thank you very much for the talk. My question is, once you've built your deep nets, do you also look inside for your insights to see why they give a certain answer, like fake or real? Are there certain features in a text that give it away very easily?
So when you say look inside,
look inside to look at the activations because a neural network ultimately
okay.
encodes knowledge, right? Unless you don't treat it like a black box, it's locked away, right? So I'm just curious whether you...
Yeah, we look into activation, but what we do is we have different hyperparameter tuning steps, and we build the model and we test it and we validate it with different parameters. So that's what we normally do, and then try to see which one is the one that provides the best results.
And what I mean is to elevate the knowledge, right? So there's something in that text, some feature that gives away it's a fake or a real item, right? So that's after you've built the model, whether you explain what your model encodes. That's what I mean.
Yeah, we try to look into why things are happening, of course, because otherwise it's just a black box. But it would also depend on what we're working on, mostly. Yeah, now you have to throw it back.
Yeah, thanks for your talk. What type of business problems are you applying these models to?
So in my team or in Zalando in general? So in my team, for example, we are trying to help teams that are more qualitative and that they have their intuition behind why things happen. For example, people that work in fashion, and try to convert those qualitative insights into quantitative insights. So for example, we can tell them, they can have an intuition of why this year brown jackets are going to be worn, but we can actually back that up with data and with insights. And they can say, okay, yeah, so now, I don't know if you know who are the buyers in a company. So the buyers are the people that make the decisions about how much and what of a certain item you're going to buy. And it's pretty difficult, because if you buy too much, then you're going to have to sell it really cheap. And if you buy too little, then you're not going to get enough money. So, for example, for that kind of people, it would be really important, because they could actually have already quantitative insights that they can decide based on that and their intuition. And that's why I said we don't want to replace the stylist or the buyers, but we want to help them. And so far, it has proven that it's been helped.
Just a question about the features, because I suppose you have fashion industry may have a lot of features like the color.
Can you speak a bit louder, please?
Oh,
or to
can you hear me now?
Yeah.
I see. Okay. Just wondering about the features you use to train the RNN model. You may have different colors of shoes, or the price, or the location, or the time of the year. How do you decide what kind of features to be used in
But for which problem, for example?
The problem, any problem you are.
Any problem I have? Well, that's a very broad question.
Maybe just example.
Well, the features that we use actually depend on the problem that we're trying to solve. So if, for example, we're trying to solve name entity recognition, we need to decide. So you mean in how we personalize those solutions, or?
Yeah, just like, I suppose you may, I don't know, like kind of whether this could be a business problem. Like, do you need to predict what time of the fashion will be the most popular for next period of time? So in the case, how do you decide what kind of features to be used?
The good thing about the deep nets is that it removes, about neural networks, it removes a lot. So there's no feature engineering as such. So it's actually the net, the ones one second. So it's actually the net, the one that so the network decides what are the most important features, and I guess that's related to his question before. If you then after look what features are, so for example, if a certain word, if the network has learned that a certain word means that this always belongs to a certain category, for example, or these kind of things. So that's one of the good things about neural networks. You don't have to be doing your handcrafted features. You will learn it automatically. I mean, you can actually input some features if you want, but.
My question is similar to this, like in any problem you solve, not only in NLP, in fashion, what are the example features, variables?
I think I cannot answer that question. There are no global features to solve a problem in fashion because fashion has too many problems. For example, my colleagues that work in customer data, their focus is different than mine. For example, their focus could be knowing to whom to advertise a certain product depending on the things that they have bought before. So it depends a lot on the problem and on the models that you are using. It depends if you're using traditional machine learning, you're using an unsupervised approach. If you're using,
for example, in machine learning, what will be your features will be?
It depends on the problem, yeah.
Yeah, in any product, because we never have we have never seen fashion in solving problems, so we don't know the variables. Like for example, in any problem you solve, suppose you are trying to predict the shoes for the next season, what will be your variables?
Well, even if I knew, I think I could not share it with you, but it depends. Are you trying to, that's what I'm trying to say, like the variables depend on, are you trying to do a prediction? Are you trying to do a classification? Are you trying to recommend an item? So, I mean, there's no global answer for fashion, and that's why it's so interesting, because there are, and sometimes in some conferences or events, they would ask, oh, why a fashion company needs machine learning or data science? Well, because we have a lot of data that we can use to solve many different problems, but not only here, like for example, picture logistics, how much money you can save if you use the data that you have in order to improve your logistics and customers, like everything. And we have a lot of different types of data. So
suppose number of customers will be one of your variables.
What?
Number of customers looking at this picture will be one of your variables.
It depends on the problem, yes. Yeah.
Hi, so I have a question regarding following Marisa's question. So for deceptive features, so to improve model accuracy, sometimes the data scientists, they create a derived feature. The new feature is based on the original feature. So do you think for the new networks, these new derived feature will help to improve accuracy or not?
Accuracy in what? Sorry, I didn't get the...
To improve the accuracy of the model, the derived feature. So you have 50 features for the products. You might add new features like the customer's loyalty, the average or max from the 50 features as new features for the model to treat.
Yeah.
So by adding new features...
So not new features, but new data. Then we are talking about new data points.
Yeah, it's the new... It's a new information based on the data we have.
Yeah.
I mean, that information you put into the network, will it improve the accuracy for the models, or the model will, the neural network will pick out these derived features automatically?
So it depends on if the features are relevant or not. If I'm inputting features that are not related to or that are providing repeated information, then it shouldn't have why, right? So if I'm inputting something that the network already knows, or that is correlated with some other feature and doesn't provide any new knowledge, no. That's why it's really important to do a rigorous experimentation, hyperparameter tuning, evaluating, testing. So that's all about the experimentation.
Okay, thanks.
Thank you.